Alright, we got our functions learning target 1.3. So this one we are actually just evaluating the function, the equation version of it. Okay? And for the first 12, we are dealing with the inputs to the outputs, and then 13, 14, 15, and 16 are given outputs going to the inputs. Okay? Thing to remember here with a function is when we're given an equation, the number inside is the input, right? Number f of x together is the output. Okay, so we use that to represent. So we're going to end up with f of some number equals some number. Okay, that's the result. So this f is just the name. We don't get rid of it or anything like that. Okay, we just deal with the pattern over on this side. Okay, because that input is represented in the pattern as well. And so we just evaluate it. That's how we do the first parts, okay? And we're usually given this number here, and we use that pattern to find that number there. So let's take a look at these. So if I look at this, p of t equals 2t minus 1. I've got p of negative 8 here. So what I do is I replace the t's with negative 8. So I go p of negative 8 equals 2, and it's 2t, which remember that means multiply. So it's 2 times negative 8 minus 1. So 2 times negative 8 is negative 16 minus 1 gives us negative 17. Now the way we like to write the answer is to then take this and stick it down here, so I have p of negative 8 equals negative 17. Right? You could write it if you wanted to as a point, but I'm okay if we just leave it like that. Okay, so that's all there is to it. Okay, now if it's an exponent like number 7, you treat it the same way. You go g of 0, right? We take that input and we replace the inputs, equals 2 times 3 to the 2 times 0 minus 1 plus 1. Okay, now this can be a little more complex, but we just take it a piece at a time, dealing with the exponent first. So 2 times 0 would be 0. 0 minus 1 is negative 1. Okay. 3 to the negative 1, whenever we have a negative exponent, that actually makes it a fraction. So I get 2 times 1/3 plus 1. Well, 2 times 1/3 is 2/3, plus 1 would give us 1 2/3. Okay, so g of 0 equals 1 2/3. Alright? Now, say it's something like this, where it's got an n cubed. We still plug it in the same exact way. So w of negative 3 equals negative 3 cubed minus 2. So negative 3 cubed would be, I don't know why be negative 3 times negative 3 times negative 3. So negative times a negative is a positive. Positive times a negative is a negative. So negative 27 minus 2 would be negative 29. So w of negative 3 equals negative 29. Okay? So now you need to try all of these first 14 right now. Pause it, then use the video to help check to see how well you did. Okay? Alright. So let's attack these. So w of negative 5 would equal negative 5 plus 4. Negative 5 plus 4 is negative 1. So w of negative 5 equals negative 1. Again, we don't touch this side once we've started. Okay, this one, clear a little space. We'd have p of 9 equals 9 plus 4. 9 plus 4 we know is 13, so p of 9 equals 13. Number 4, g of 0 equals 3 times 0 minus 2. 3 times 0 is 0. 0 minus 2 is negative 2. So g of 0 equals negative 2. Okay, number 5, g of negative 8 equals 4 times negative 8 plus 1. 4 times negative 8 is negative 32 plus 1 is negative 31. So g of negative 8 equals negative 31. Number 6, p of 7 equals 2 times 7. 2 times 7 is 14. b of 7 equals 14. Okay, 7 we already did. Number 8, we would have h of negative 2 equals 4 to the negative 2. And like we said, a negative exponent becomes a fraction, and that makes it positive. So I'd have 1 over 4 squared, which would turn into 1. 4 squared is 4 times 4, which is 16. So h of negative 2 would equal 1 over 16. Okay, number 9, h of 0 would equal 2 times 3 to the 3 times 0. 3 times 0 is 0. Anything to the 0 power is 1, so I'd have 2 times 1. So I'd have h of 0 equals 2. Alright, so we've done number 12, but I need to clear some space. Okay, so we've got number 10 now. So h of 2 equals 3 to the 2 times 2 plus 2. 3 squared is, 2 times 2 is 4, so 3 to the 4th plus 2. 3 to the 4th would be 3 times 3 times 3 times 3, which would be 9, 27, and 81. So 81 plus 2 would give us 83. So h of 2 equals 83. Okay, so hopefully we're seeing that this isn't too difficult. W of 7 would equal 7 squared plus 4. 7 times 7 is 49, plus 4 would give us 54, or not 54, 53. So W of 7 would equal 53. Okay, number 13, F of 12 would equal 12 minus 4. 12 minus 4 is 8. F of 12 would equal 8. And G of 14. Oh crap. I did number 13 wrong, didn't I? I thought... Okay, and this is a mistake people will make. This was W of 7. This was F of t equals 12. Okay, we treat these ones differently. So, so now the idea here on this other type is that now we're told f of x equals something. Okay, so we are given the output, we're given this, so we're going to replace that with that number because they're equal. We can do that. And then what we want to do is find the input because we're given the output of 5, so we want to know what input would make this work. So now we have to solve. So I'd have to subtract 1 to give me 4 equals 2x, divide by 2, and get 2 equals x. Okay, so that's how we treat 13, 14, 15, and 16. So instead of f of t, I change that to 12 equals t minus 4. Then I solve for t by adding 4, and I get 16 equals t. So that tells me f of 16 equals 12, okay? Because 16 equals t, the input, when the output is 12. Okay, 14. Instead of g of a is the same thing as 19, so I go 19 equals 4a plus 3, subtract 3 from both sides. I get 16 equals 4a, divide by 4. 16 divided by 4 is 4, so 4 equals a. So again, g of 4 would equal 19, but when I'm given the input, there's my output. Okay, so 15, w of n gets replaced with 81, so 81 equals 3n plus 3. Subtract 3, and 81 minus 3 would give us 78 equals 3n, divide by 3, and 3 goes into 78 twice, and 6 times. So 26 equals n. And there's our answer. And then finally, number 16, g of x becomes negative 43. So negative 3x minus 4. We add 4. That becomes negative 39 equals negative 3x. Divide by negative 3. And we get a positive 13 equals x. Okay? Alright guys, so that's really all there is to it on these solving equations. Again, these 4 down here, if we're given the output, we solve. If we're given the input here, then we just evaluate. And there we go.